Hello everyone, I'm Dr. Kamal Malik, professor at CT University in the Department of Computer Science and Engineering. I'm going to deliver my lecture today on machine learning. We'll start from basics and deep dive into it. So let's start. So we are having few outlines of course like introduction, linear regression, instance-based learning, probability and Bayes learning, support vector machines, neural network, introduction to computational learning theory. These are basically the parts of the machine learning that we will try to cover. So starting with the machine learning history, first of all, how the machine learning evolves. Machine learning is basically the subset of the artificial intelligence that we are going to train the machines according to our need. First of all, it was evolved in 1950s where Samuel Checker playing program was first of all created, and then 1960 we were having neural networks by Rosenblatt's perceptron. That was the unit perceptron made by him. Then Minsky and Papret, they proved the limitations of the perceptron. After that, in 1970s, some more advancements were done on it, like symbolic concept induction, expert systems and knowledge acquisition bottleneck, Quinlan's ID3, and then natural language processing, which is very much famous and utilized nowadays. Then we are having in 1980s, the more advanced decision trees came, then rule-based learning came. After that, learning and planning and or the problem solving techniques were emerged through the machine learning, and then resurgence of neural network was there, variants, PAC learning theory was there, then focus on the experimental methodologies was there, and in early 1990s ML and various statistics were used, and machine learning was basically used in by different statisticians in different statistics like data mining, adaptive agent and web applications, text learning, reinforcement learning, and sampling based net learning. And in 1994, finally, the self-driving car by Tesla was launched and the road test was done. And in 1997, Deep Blue beats the Gary Kasparov. So these were the history basically, and popularity of this field in recent time has really gone so much. They are so much trending nowadays, and the reasons behind that is we can have new softwares, we can have new algorithms of neural networks, deep learning. Hardware is new. If the software is new, then we cannot rely on the traditional hardware like central processing units or CPU. No, we need to switch on the GPUs. Then cloud enabled availability of big data. So these are the things. Now, what are the different applications that we have got still now? In 2009, Google builds self-driving car. In 2011, Watson wins Jeopardy. In 2014, human vision surpassed by the ML systems. So the first thing that we must know that what is the difference between the programs versus learning algorithms. What is the simple program and what is the machine learning program? Difference between the simple program done by the languages like C, C++, Java, and how it is different from the machine learning program. In simple algorithmic solutions, we give data and program as input, and computer take that input and provide the output. But machine learning solution is altogether different. Here data and output is provided, and computer takes the data and output, and finally it makes the program out of it. It is the input that actually given by the program. It is that input is in the form of predictions. That input is in the form of various constraints, predictions, various assumptions that we can do to get the desired solution. So now we come to the machine learning definition. Learning is the ability to improve one's behavior based on the experience. We can build computer systems that automatically improve with the experience. What are the fundamental laws that govern all the learning processes? Machine learning explores algorithms that can learn from the data, that can build a model from the data, and that can use the model for prediction also. So decision making, it helps in decision making, solving some very important tasks. Then we come to machine learning definition. Now, how we can define the machine learning, that is very, very important. A computer program. Machine learning is nothing but a computer program that is set to learn from itself, that is set to learn from the experience E with respect to sum of the class of the task T and performance measures P. If its performance at tasks in T as measured by P, it improves with the experience E. Then we are having components of learning problem. There are many components. Any problem that is learned, basically we are not able to train the machine, we are basically able to train the softwares. It is the software that will become learned. It is not the machine that becomes learned. Okay. So we are having various components of learning problem. The first component is task. The behavior or task being improved. For example, classification, acting in an environment. The number 2 is data. The experiences that are being used to improve the performance in the tasks. And the third thing is measures of improvement. For example, increasing the accuracy in prediction, acquiring new improved speed and efficiency. But I would like to tell you that it's like a black box learner problem. Black box learner problem means if we give some task to the machine, you are not aware of what is the internal coding of that AI. And you will get the final output out of it. You are not aware of the internal coding. So experiences and data is sent as an input, problem and tasks are sent as an input, and background knowledge is sent as an input, and we are not aware what is happening inside, and further we will get the answer. But nowadays it is possible that we understand what is the internal coding because we are very much particular with the problems. When internal coding is known, then we come to the next level of artificial intelligence, which is known as explainable AI. Okay, so how the learner goes. This is a learner get the experiences and data. There is a problem or tasks. Then we are having the background knowledge and bias. Ultimately, the learner will get the answer in the form of performance. Then there are many domains and many applications where we use the machine learning. For example, number 1 is medicine. We can diagnose a disease. Now, how the disease can be diagnosed? Number 1 is input is given. What are the symptoms of that disease? What are the lab measurements of that disease? What are the test results? What are the DNA results? And we will get the output. One of the set of the possible diseases or none of the above. Then the third thing is we will take the data from the historical records. Every time when you put such type of record, input, symptoms, lab measurements, task results, our software get trained of it. Yes, with this system, this disease can happen. With this systems, this cluster of diseases can happen. So automatically this is known as the training part of the software, and our algorithm get trained out of it. So if we want to learn, and in this way software learns that which future patients will respond best to which treatments. Then there are many domains and applications like vision. Say what objects appear in an image. Then convert the handwritten digits to the characters like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And detect where the objects appear in an image, where the objects are appearing in an image. Then we are having many domains and applications. Another very important domain is robot control. Design autonomous mobile robots that learn from experience to play soccer, to navigate from their own experiences. So this is the very important thing. Then another, we are having natural language processes, which is very famous and trending nowadays. Detect where the entities are mentioned in NL, natural languages. Detect the facts that are present in NL. detect the product or movie review is positive, negative or neutral. It will take all the comments, do the sentimental analysis on it and go to the conclusion that yes, the movie was good, the movie was bad, the movie was on an average, it was just like that. So speech recognition, machine translation, these are all very important. Then we are having many domains and applications. Financial, first of all, I'm talking about the financial domain. It will predict if a stock will rise or falls. It will predict if a user will click on an ad or not. Then we are having the applications in business intelligence. It can forecast the product sales, quantities, taking the seasonality and trend into account. Then it can identify the cross-selling, promotional opportunities for consumer goods. It takes the count of the inventory, that how much inventory should be in the stock and how we need to deal with that inventory and so on. There are so many things. Other applications are fraud detection. Fraud detection is credit card providers. For somebody, if you are doing a shopping of say 10 to 20,000 every month from your credit card, all of a sudden you are doing the shopping of say 50,000 or 1 lakh from your credit card, then it will become an outlier. The resource person will ask you about your identity, that it is whether it is you or not. So determining whether or not someone will default on a home mortgage, this is all another thing. Understanding consumer sentiment based off of the unstructured text data. I have already told you, when we post some picture, there is a picture and you are giving different comments in that picture, then the sentimental analysis of the comments that you give on a picture, maybe it is on Insta, maybe it is on Twitter or maybe it is on Facebook, that comments are analyzed, and with the analytics of that comments, it will give you some new review or new conclusion out of it. So forecasting women's conviction rates based off external macroeconomic factors, this is another thing. Now we come to the learner. Again, I'm telling you, the experience data, problems, various tasks, problems in the form of various tasks, background knowledge in the form of bias. It will give you the natural answer in the form of experience. So design a learner. How a learner is designed? Again, choosing the training experience. Choosing the training experience is the first very important task. The second thing is choose the target function that needs to be learned. The third thing is choose how to represent the target function. Choose a learning algorithm to infer the target function. Choosing a model representation, how to choose that model representation. The richer the representation, the more useful it is for subsequent problem solving. The richer the representation, the more difficult it is to learn. So what are the components of representation? Number one is features. The second one is function, class or hypothesis language. So there are some few broad types of machine learning. The first one is the supervised learning. The second one is the unsupervised learning. Supervised learning, machine learning is the learning where we are already having the labels with us and we put the data according to those labels. We will categorize the data in those labels. Already labels are available in the supervised learning, but in case of unsupervised learning, we are not aware with the labels. We don't have labels with us. According to the characteristics of the data, we put them into the one cluster. Then the another, by seeing their characteristics, we put the another bunch of the data into the another cluster and so on. The third thing is the reinforcement learning that determines what to do, that will be completely based on the rewards and punishments. So this there is another semi-supervised learning also. Semi-supervised learning is the mixture of supervised learning and unsupervised learning, for which for few of the data sets we do have labels, but for few of the data sets we do not have any kind of labels. Then we come to supervised learning. This is the way how complete I am telling you. This is the input, output and all given. learning algorithm is there, you will give the model, new input is there, model will be made and the output is there. Then in unsupervised learning, we will have different clusters, input is there, clusters are formed. Then in semi-supervised, this is the way we can do. We are having labeled data, we are having unlabeled data, we are having mixture of labeled and unlabeled data. They are separated like this as shown in the figure D. Now in reinforcement, again we will have an agent as well as environment. Agent will perform some action. Environment, from environment, the state of the agent with that action will be changed, whether it will be rewarded for it or punished for it. If reward is given, agent will do the another action accordingly. But if for some task, if the agent will be punished, then its action will be changed accordingly. So reward and punishment are the very important things in the reinforcement learning. So this way it will go on. There must be some policy with the help of which an agent will perform the thing. Now in a supervised learning, if mathematically I want to understand, I want to tell you mathematically, then I am giving you a set of input features, say x1 to xn, then we are having the target feature y. A set of the training examples are there where the values for each input feature and the target features are given for each example. Now new example where only the value for the input features are given, then we need to predict the values for the target features for the new example. Then its classification is the example. Classification is an example of supervised learning where we are having different classes and the value of y will remain discrete. This is the very important thing where we knew we need to use classification and where we need to use regression. If the target value is discrete, we will use the classification. But on the other hand, if your target value is not discrete, it is say in fraction, then we will use regression. Okay, then we come to classification, credit scoring. This is another very important part of classification, that is credit scoring, like this, high scoring and less scoring, differentiating between low risk and high risk customers from their income and savings. Then we come to regression. Regression is very important. For example, there is a price of a used car. I want to predict the price of a car depending upon the how much is the mileage of the car. How much is the mileage of the car? I want to predict the price of the car. So X is the car attributes, Y is my price, Y is equal to, means my price is a dependent variable on various dependent variables on X. X means the attributes of car and theta, G X of theta. This is the function that we are having, G X of theta. G is the model and theta are the parameters. Then we come to features. Often the individual observations, they are analyzed into the set of the quantifiable properties which are called features. We are having few features with us: categorical, ordinal, integer value, real value. Then we are having some example data with us, training example. For example, from E1 to E6, we are having this much of data. And what about the new ones, E7 and E8? How they will be given? So if I have a full understanding of from E1 to E6 examples, then definitely I can also have an understanding of E7 and E8. I can predict what would be the value of E7 action and what would be the value of E8 action. This is what basically the regression is. So in the training set, basically what is happening, we are having a training set, we will apply the learning algorithm on it, then hypothesis will be conducted, then X is given, that is the testing, then we are having predicted Y, and finally we will get something out of it. So training phase mein kya hota hai? We are having input, then feature extractor, features, we are having learning algorithm is applied, classifier model is there. This is the way training. Training means, if for example, if you have some kids in your house, you train them first how to behave when someone comes in your house. Similarly, we have to train our data set, train basically the machine learning, our software for that particular data, that for particular training phase our machine is supposed to do like this. For 80% of the data we are doing that training. How the training is given? Labels are given to the machine, inputs is there, feature extractor is there, feature extraction and feature class selection is there, and then machine learning algorithm is applied. After that, for 20% of the data we are having the testing phase. For testing phase again we are having feature extractors, features, but here now we will apply the classifier model, and for that tested data it will classify the entire data into different classes of its own. Now our machine has learned. Now classification learning mein we are having test T, input and output. The second one is the performance metric P, and then is the experience E. So classification learning, it comes to task T input, a set of the instances D1, D2, D3 up to Dn. Then instance has a set of the features. We can represent an instance as a vector D, x1, x2 up to xn. Then output, a set of predictions, one of the fixed set of the constant values that we have, +1, -1, person is healthy, person is having cancer, person or flower is rose, hibiscus or jasmine, etc. So performance metric P, experience E. Now what we need to do is classification learning. For example, medical diagnosis, we can apply the classification in it. +1, -1, this would be the labels. I'm giving you examples. For finding entity names in the text, 0, a word in the text capitalized 0 or 1, this would be the example, first, later, outside. For image recognition, this would be the example. So this way we can do it. So classification learning mein kya hota hai? What we need to do is task T is there. T means input, a set of instances, that is D1, D2 up to Dn. Then output, we are having a set of predictions, Y1 cap, Y2 cap up to Yn. Then performance metric is P. It will be probability. Probability means it can be a wrong prediction, it can be a right prediction. We care about the performance on the distribution, not on the training data. This is very important. Finally, we are having experience. Now, I think my definition of machine learning is now into the paper that I have already told you in the previous slide. This is the performance, and experience E would be a set of the labeled examples x, y, where y is the true label for x. Ideally, examples should be sampled from some fixed distribution T. Then these are the examples that we have given you. Now there are few representations: decision tree, linear function. Now decision tree is what? If you say, yes, today is a weekend, yes. If it is a weekend, yes, it's Saturday night, you will go eat out in some restaurant or hotel with your family, okay? But if it is not a weekend, late. If you are late, then yes, you will go for eat out. If you are not late, you will say, let's cook at home, okay? So we will remain at home. So this is the way we are going to take the decisions. This is the way how we are going to take the decisions. Similarly, linear functions are also there, that if higher the school GPA, there is a possibility that higher the university GPA. If some student is getting failed in the school, the probability is that maybe he will get failed in the university also. So representation, this is the multivariate linear representation, then single layer perceptron, and this is the way how we get the single layer perceptron. We are having various inputs, x1, x2 up to xn. Every input has an associated weight with it, weight 1, 2, 3, z, and then there is a transfer function which is known as sigma, okay? Transfer function has a sigma, net input is there, activation function is there, activation function is applied, and this is the threshold. Whatever the answer that we will get from this sigma output, then we need to check it through the threshold, whether it is crossing the threshold or not. Yes, if it is crossing the threshold, then we will get the final output, it is okay. Otherwise, if it is not crossing that threshold, we will throw it out. something like that. We have to put the final function over here. Okay, then we are having multi-layer neural network. There are many hidden layers in it, and when the many 40 to 50 layers becomes deep learning. So this is the way how we go for hypothesis space. When we are talking about hypothesis space, one way to think that a supervised learning machine is a device that explores a hypothesis space. Each setting of the parameter in the machine is a different hypothesis about the function that maps input vectors. Now, what are the terminologies? Number one is feature vector, instance space x, then example xy. Talking about features, the number of the features or distinct traits that can be used to describe each item in a quantitative manner. Then feature vectors are there. They are n-dimensional vectors of numerical features that represent some objects. Then instance space x is there, set of all the possible objects describable by the features. Then example xy, instance x with a label y is equal to fx. Then we are having terminology, concept C, target function F, example xy, training data. So thanks a lot from my side. This was the basics of machine learning. I hope you have learned from it. Thanks.